Hey guys, so sorry that I had to cancel class today, but I still wanted to go over the practice sheet for anybody who needs it, or anybody who's confused. If you have more questions after, please let me just comment or let me know somehow, whatever. I am gonna tell you, we are having a quiz next week. It'll just be over transformations in standard form. The factoring won't be on there. So anyway, make sure you understand that. There will be a review next week to prepare for the quiz. Anyway, so I'm going to go through this. First off, when doing transformations, I always say it's good to start with the vertex. So when pulling the vertex out, you're using these two numbers, but okay, well, you want to flip the sign of what's in parentheses with x. So the vertex in this case will be -4, 4. So here's my vertex. Because the parent function starts at 0, 0, we know that it went left 4 and up 4. And then when there's a is 2, so since it's positive, the parabola will be going up. And 2 is a stretch, which makes it a little bit more narrow. So it'll look something like this. Remember that you can always check yourself by going to geogebra.org/calculator or gizmos.com/calculator or using an actual graphic calculator to look at the graph. There's no shame in that. You know, we have technology, might as well use it. The last thing it asks for is domain and range. So domain for quadratics will always be our numbers. And the range. So we're looking at the y's there, and everything is above the vertex. So I'm going to say that all of the y's are greater than or equal to 4. The next one is standard form. So the first thing we want to do is find the vertex. If you have a hard time finding the vertex, check the graph. You know, the vertex is pretty easy to find from a graph. It's the middle point / the highest or lowest point, depending on which direction it's going. So I'm going to use the formula, though. I can't write the formula on the board for you because we're not in school. So if you haven't written this down, I recommend that you do. So with standard form, I've got A, B, and C. So for the x of the vertex, I'm going to do -b over 2 times A, which ends up giving me +4 divided by -4, which is -1. So that's the x of my vertex, or the axis of symmetry. For the y, I just take that in and plug it into the equation to see what the y would be. So -2 times -1 squared minus 4 times -1 minus 6. Figure all that out, you get -4. So my vertex is at the point -1, -4. Since A is negative, it's the parabola is going to be going down. And since A is a number that's bigger than 1, or no, the magnitude is bigger than 1, it's a stretch, so it's going to be more narrow. So it's going to go down. Like that. And be more narrow. Yeah. So my vertex is at -1, -4. To put that in vertex form, I start with like this outline of vertex form, right? And then I'm just going to plug the numbers in. So the x goes with the x, but I have to flip the sign. The -4 goes at the end. And whatever A is goes in front. Yeah. Okay, so that moves us on to factoring. Factored form looks like this. Right, you're going to have two sets of parentheses with x's in there. And basically what you're doing is you're trying to find numbers that multiply to the third number and add to the middle. So the only way to get good at factoring is to practice it. I suggest that after I do the first like couple ones of these that you pause it, try them on your own, and then check yourself, because literally the only way to get good at it is to practice it. It's a weird skill. It's not like some other things in math where you can just follow the same formula every time. You actually have to think about it. It's like breaking numbers apart and putting it back together in different ways. So it's a tricky skill. So don't get frustrated if it's difficult for you. It's difficult for a lot of people every year. But anyway, so what I suggest doing, if you can't, if you have a hard time with this, is to literally just list off the different ways to multiply up to 24. So start by dividing by 1 and work your way up until you start repeating yourself. So like ways to get 24. I can multiply 1 and 24, 2 and 12, 3 and 8, 4 and 6. 5 would end up giving me a decimal. And once I get to 6, I'm repeating myself, so I'm done. So now I have to figure out the ones that I can add up to -10. So there's no way to get 10 by adding or subtracting 3 and 8, 1 and 24. So I could subtract these to get 10, but since I have a positive one here, the signs need to be the same, so I'll be adding. So I'm going to use 4 and 6. So since I want them to add up to -10, I'm going to make them both negative. So the my brain has failed me. I need to look back. Give me a second. What am I saying? Right. So once you do this, I suggest that you test yourself. Multiply them together. Make sure that they equal 24. They do. Add them together. Make sure they equal -10. They do. Hooray, we did also. Super cool. Okay. With this one, whenever you can, you always want to pull out a greatest common factor first. So if all 3 terms or all 2 terms or however many terms you have all have something in common, it's called factoring it out. Okay, so both of the numbers can be divided by 2 and they both have an x. So I'm going to write 2x out front, and then I'm going to divide everything by 2 and take away one of their x's. So in this case, it'll just give me x. Here, it'll give me 6 because I divided by 2 and took away the x. Now, at this point, there's no more squared, so I'm done factoring. That's all I can do. Okay, so sometimes that happens. Sometimes you pull out a greatest common factor and you're done. All right. With this one, again, I want to pull out my greatest common factor, which will be 5. So I'm going to divide everything by 5, and I get x squared plus 4x minus 45. But I still have an x squared in there, so I still have to factor. So I'm going to need to find 2 numbers that multiply to -45 and add to -4. So let's go ahead and list off what we can multiply to get 45. So I've got 1 and 45. 2 would give me a decimal. 3 and 15. 4 would give me a decimal. 5 and 9. 6, 7, and 8 would give me decimals. So there you go. That's it. Looking at these pairs, 1 and 45 won't ever get me close to 4. 3 and 15 won't, but 5 and 9 will. So I'm going to use 5 and 9. Just so you know, it doesn't matter which order you put them in. So when I add them together, I need to get a positive 4. So to do that, I'm going to make it a plus 9 and a minus 5. Because when I add those together, I get positive 4. When I multiply them together, I get negative 45. So the signs are the things that people mess up on the most. So that's just something to be careful of, mindful of, you know. Anyway. Okay. Next, here. Again, both terms have something in common. They both have an x. So I'm going to start by factoring out an x. Once I take away an x from both of them, though, I don't have an x squared anymore. So I'm done. The end. This one, there's no greatest common factor, so I'm just going to go straight into factoring. I need to find two numbers that multiply to 8 and add to negative 9. So I'm going to list off the things that multiply to 8. I've got 1 and 8, 2 and 4. That is all. Nothing else will multiply to 8 unless you use fractions or decimals. So which one gives me 9? Well, it's the 1 and 8. So 1, 8. I want them to add up to negative 9, so I'm going to make them both negative. That way, when I add, I get negative 9, but when I multiply, I get positive 8. Next, greatest common factor again. So I'm going to factor out a 6. Once I divide everything by 6, I end up with x squared minus 6x minus 40. So I need to factor. So I have to find two numbers that multiply to 40 and add to negative 6. Multiply to negative 40 and add to negative 6. So to do that, I'm going to list off the stuff that multiplies to 40. I got 1 and 40, 2 and 20. 3 would give me a decimal. 4 and 10, 5 and 8, 6 and 7 would give me decimals. So those are all of my factors. The ones that can get me to 6. The only ones that can do that would be 4 and 10. So now I got to figure out if I want pluses or minuses. I want to get negative 6. So that means I'm going to make it a negative 10 and a positive 4. If I add those together, I get negative 6. If I multiply them, I get negative 40. Boom. Okay, this one. No greatest common factor, so I'm just going to go straight to it. Need two numbers that multiply to 45, but add to 14. So things that multiply to 45, I've got 1 and 45, 3 and 15, 2 would have given me a decimal, 4 gives me a decimal, 5 and 9, 6, 7, and 8 will give me decimals. So, ooh, ouch. Okay. Well, ow. That's over here. So which ones add up to 14? Why, you're right. If you said 5 and 9, they will. So I want positive 14, so that means they're both going to be plus. Adds up to 14, multiplies to 45. We are good. Moving on. Here, greatest common factor. Got to divide everything by 4 first. So I've got x squared minus 6x plus 8. Now I can factor. So I need to find two numbers that multiply to 8 and add to negative 6. So the only things that multiply to 8 are 1 and 8, and then 2 and 4. Which ones add up to 6? If you said 2 and 4, you'd be right. So I want them to equal negative 6. So that means I need to make both of them a minus. That way when I multiply, I get positive 8, but when I add them, I get negative 6. Okay. So here, no greatest common factor, so I can just go straight into factoring. Multiplies to 24, but adds to 10. Let's figure out what multiplies to 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. If you'll notice, this is just like the one up here, right? Except this time I have a positive 10. So again, I'm going to use 4 and 6. But in this case, instead of minuses, I want to put pluses because I want positive 10. It does bear to mention that if you ever had y equals x squared plus 10x minus 24, in that case, I would use 2 and 12 because I would need different signs, right? Because they would have to multiply to a negative number. So in that case, I would want plus 12 and minus 2 so that they would multiply to negative 24 but add to positive 10. Just something to be mindful of. Like I said, these can get tricky, but there's always only one right answer. Sometimes you can't factor them out. I'll never ask you to factor something that you can't factor though. I won't. Math teachers in the future may. So yeah, some of you will. All right. Last one, factoring out of 3. So I'm going to divide everything by 3 and I get x squared minus 2x minus 35. So that I can factor. I need things to add up to negative 2 but multiply to negative 35. So things that multiply to 35, we're going to have 1 and 35, 5 and 7. That's it. So which ones give me 2? Well, 5 and 7 happen to only be 2 apart from each other. So I want to get negative 2. So that means that I'm going to have a negative 7 and a positive 5. Because when I add those together, I get negative 2. Multiply them together, I get negative 35. Anyway, so I know it's a video and I probably went kind of fast. But you can pause, rewind, fast forward, whatever you need to do. Just make sure you understand what's going on. Again, sorry I had to cancel class. If you have questions, please let me know.